Welcome to This Explainer. Today, we are diving into the exact strategies you need to master a topic that notoriously trips up even the best students. We're talking about the use of stacks in Recursion for the Cambridge AS and A-Level Computer Science exam, syllabus code 9618. Now, I want you to think of this session as your ultimate wizard's playbook. In the world of Cambridge exams, magic spells aren't just fantasy. They are the structural frameworks you use to formulate your answers. If you cast the right spell, you get maximum marks. If you don't, well, the examiner makes your marks disappear. If you've been struggling to figure out exactly what to demonstrate when they test this concept, you are absolutely in the right place. Let's get into it.
Look at this quote right here. A senior examiner recently noted that most students lose easy marks on use of stacks in recursion. But here's the thing, you are not going to be one of them. To understand why this happens, let me introduce you to two classic types of students. First, we have Alex. Now, Alex overloads his exam paper with raw computer science facts. He writes a massive generic paragraph about last in, first out memory, but includes zero actual analysis of the code provided. Then we have Sam. Sam rushes through the paper, completely misses the specific command word requirements, and just scribbles down a final return value without showing any stack frames. The result? Both of them lose massive points, despite knowing the basic theory. We need a better strategy. Here is our roadmap for today's explainer. We're going to cover the core principles of recursion, the procedural framework, evaluating algorithm efficiency, top examiner warnings, and finally, the method mark strategy. We are taking you from the foundational theory all the way up to the critical exam techniques that graders are desperately looking for. We're going to fix the mistakes that Alex and Sam are making once and for all. Okay, Section 1, Core Principles of Recursion. Before we can write those flawless, high-scoring answers, we need to establish the exact cognitive domains you are being tested on when dealing with stacks and recursion. It's not just about writing a block of code. It's about fundamentally proving how you think. Let's break down the spell components. To succeed, your answers must demonstrate a mastery of these three specific domains: knowledge and understanding, application, and analysis. When evaluating your response to a recursion question, they aren't just checking if the final output is right. They are looking for logical, highly structured reasoning. To do this, top students use a framework called PEAL. That stands for point, evidence, explanation, and link. That is your core spell. When you explain how a stack uses LifePhone memory to manage recursive calls, you don't just state a fact. You make your point, provide evidence from the prompt's code, explain how the stack frames push and pop, and link it back to the algorithm's ultimate purpose. Let's look at a direct comparison. Cambridge's assessment framework heavily prioritizes analytical depth over superficial breadth. Remember our student Alex? Alex's answers have superficial breadth. He memorized a dictionary definition of a stack. But examiners want analytical depth. They want you to use the PEAL framework to prove you understand why this specific data structure is absolutely necessary to securely store the state of local variables and return addresses during a recursive subroutine. It's the difference between saying a stack holds data and this specific stack frame preserves the local variable x so it can be resolved when the base case is finally met. Interestingly, principal examiner reports explicitly highlight that candidates referencing cross-topic connections achieve significantly higher marks. Top-performing students show connected conceptual understanding. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, back to cross-topic connections. This means integrating your knowledge of stacks with other syllabus areas like memory management or processor architecture. If you can draw those connections, you are operating exactly how top-tier candidates operate. Moving right along to Section 2, the procedural framework. Now that we know the conceptual expectations, let's look at the transformation. We are going to break down the step-by-step procedural framework for actually tackling these questions in the exam hall so you don't end up rushing like Sam. By following this standardized 5-step sequence, you guarantee a systematic process that perfectly aligns with what graders are scanning for. 1. Deconstruct the command word. 2. Extract the relevant data from the pseudocode. 3. Select your analytical framework, like PEAL. 4. Execute your analysis with clear notation. And 5. Present it with correct terminology. If Alex and Sam used this exact sequence to rewrite their answers, we'd see their red pen marks instantly transform into green check marks. This is the computer science success blueprint. Beyond that written sequence, your practical application must constantly loop through these 4 core skills: designing algorithms, implementing solutions, testing thoroughly, and evaluating performance. This is the heartbeat of computer science. When you are mapping out a recursive function using a stack, you need to mentally walk through this cycle. Test your own logic. Does the stack push the right parameters? Does it pop them in the correct sequence when the base case triggers? And remember, your data interpretation skills are absolutely critical here. The syllabus specifically notes that you must be able to extract data from binary representations, perform calculations, and draw evidence-based conclusions. If a question asks you to trace a stack's memory addresses in binary during a recursive process, you need to execute that flawlessly. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams at Ace the Exams IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's jump into Section 3, Evaluating Algorithm Efficiency. This is where we demand higher order thinking. Why do students find evaluating algorithm efficiency so incredibly hard? It's a common stumbling block. You might be able to trace the recursion perfectly, but evaluating its efficiency leaves you staring at a blank page. To fix this, we are going to do our first interactive workshop right now. Challenge 1, Data Scan. I am going to put 60 seconds on the clock, and I want you to look at the upcoming table and extract the core trend for how we measure efficiency. Ready? Let's look at the criteria. The timer is ticking. Look at these 3 criteria. Whenever you are evaluating algorithm quality, especially regarding recursion, you must explicitly identify time complexity, space complexity, and edge cases. In a recursion question, the core trend you should have extracted is space complexity. Because every single recursive call adds a brand new frame to the stack, memory usage scales rapidly. If you don't mention the memory overhead of stack frames when evaluating a recursive algorithm, you're throwing away points. Time is up on that challenge. Let's keep moving. To secure those top-tier marks, you need to hit these higher-order objectives using that Peel framework we discussed earlier. Ensure you are evaluating alternatives, like comparing a recursive approach to an iterative approach. Compare the different structural approaches, and always justify your final recommendations. If you claim that an iterative while loop is better for memory than recursion in a specific scenario, you must explain why using the concept of stack frames.
Section 4, Top Examiner Warnings. Where are students dropping the ball during the exam? It is time for Challenge 2 in our interactive workshop, Find the Flaw. I am going to show you exactly how students like Sam lose their marks, and you have to identify why. Principal examiner reports explicitly show a massive divide between vague technical details and context-specific answers. Imagine Sam writes this paragraph. The algorithm uses recursion. This needs it calls itself. It uses a stack to remember things. A stack is LIFO. Look at that paragraph. Can you find the sentence losing marks? I'll give you a hint. It's the whole thing. It is incredibly vague, it lacks specific technical details, it does not use the Peel framework, and it does not tie back to the specific context of the prompt. Here is the examiner commentary on those exact mistakes. Make sure you memorize these top 3 warnings. Number 1, answers are often too vague. You must provide specific technical details about the stack operations. Number 2, students forget to check boundary conditions and edge cases, which is exactly where recursion usually breaks via a stack overflow. Number 3, answers are not specific to the context given in the question. Always ask yourself, could my answer apply to any recursion question or only this specific code? If it's the former, you fail the test. Section 5, the method mark strategy. For our final section, we are going to look at the most powerful tool in your exam arsenal. This is your ultimate safety net. There is a massive examiner alert you need to be aware of. Students consistently lose marks by not showing working. This brings us to Challenge 3, Speed Writing. When an exam asks you to trace a recursive function, you have to show every step. Imagine you have 30 seconds on the clock right now. You need to write one perfect Peel paragraph explaining how the base case stops the stack from overflowing, or you need to physically draw out the stack frames. Don't hide your algorithmic thinking in your head. Put it on the paper. Because here is the incredible truth. Even if your final answer is completely wrong, method marks can save you. This is why our final system relies on 3 rules that guarantee top marks. Rule 1, command word decoding. Know exactly what they are asking. Rule 2, Peel framework application. Structure your logic perfectly. Rule 3, time management matrix. Show your work efficiently. If you visually document your procedural sequence, drawing the variables being pushed and popped, clear notation is rewarded. If you mess up the final addition at the end, you still get the method marks.
Your working out must clearly display these algorithmic thinking essentials. Show your step-by-step decomposition. Explicitly mention your appropriate data structure selection, which is the stack. Demonstrate efficient code implementation and rigorous testing. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos.
Which brings us to our final question. Have you rigorously mapped out your stack procedures to ensure every possible method mark is captured? Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel at your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.